Imagine a world that everyone can build and use their own machine learning technology to make smart predictions without any machine learning expertise or no coding. Well, that world is here, and I'm personally very excited to introduce you to SageMaker Canvas and how it can scale the value you're getting from machine learning initiatives. My name is Kostis Vasilakakis, and I'm the head of product growth for AWS's low-code, no-code machine learning. And in today's session, we'll go deep into Canvas. We'll show what it is, what use cases you can solve for, and how you can leverage it in your business. But before we start with the presentation, let me ask the audience a couple of questions, and if the answer is yes, please raise your hand. Are you a data scientist or work within the data science team? Great. Do you own or are part of a team that owns the machine learning platform team in your organization? Okay, great. And are you joining us from the business side? Are you an analyst, domain expert, or a business executive? Cool, perfect. That's, I'd say, 30, 20, 50 split. So let's discuss today how we can bring all those worlds closer together and scale the value you're getting from your machine learning initiatives. We'll start the session by discussing how machine learning is being built right now and what are some of the issues in actually expanding the amount of use cases your organization solves with machine learning are. Then we'll discuss how you can scale that value by enabling the business teams to solve for those problems by building and using their own machine learning models and using our no-code technology called Canvas. And then we'll go deep into Canvas in terms of understanding the capabilities, understanding the features, understanding the use cases, and doing a live demo to see the simplicity of the tool. And then we'll invite on stage Mark Newman, BMW Group's AI platform product owner, that will walk us through their ML journey so far, as well as describe how they're going about scaling the machine learning initiatives right now within their organization. And lastly, before we open it up for questions, I'll showcase very quickly how you can access it right for you to see the power of it. So how machine learning is being built and drives value right now? It usually starts with a business case and a set of requirements that can drive value for an organization. For example, one might want to predict which of the existing customers will churn in the next month or two so that they proactively react over it. Another might want to predict the inventory they need over the next couple of months so that they satisfy the demand. Another might want to predict how many of the leads, the sales leads they have right now, will actually convert into paying customers. And the list goes on and on and on to a lot more and to a lot more complex use cases that might involve computer vision, natural language processing, and many more. And what happens frequently is that the business teams have a long list of those use cases and requirements. And at the same time, the data science teams have a long list of backlog that they need to go through. So in reality, they sit down and they discuss what is the true value of each use case, what is the complexity, and given the amount of resources the teams have right now, which ones to focus on. So let's assume, in our example, the team wants to focus on the sales conversion. What happens next? The data engineering and data science teams have to source all the data across the different data sources. They have to join them, clean them, standardize them, and eventually they have to start a process of feature engineering for the particular problem they're trying to solve. And then the data scientist team has to actually build models that are appropriate for that particular problem. And then they have to iterate on different features and different models and different hyperparameters on top of those models to optimize for the best combination of all. And once they're done, they have to give the best model to their MLOps teams to productionalize it and make it accessible to the business teams. Our customers, though, say that this process is very iterative, takes a lot of expertise, and takes a lot of time, making the teams just focus on a very few prioritized use cases and not the whole list of the use cases that they want to solve for. So the question becomes, how can you actually scale the value you're getting from machine learning today? And I'd argue there's 3 ways you can go about it. First, you can help increase the productivity of your data science teams. And that's the very point and the very value we're bringing with SageMaker and SageMaker Studio specifically, where that is the unified pane of glass of all features across the machine learning workflow that we provide with SageMaker. From data labeling, feature engineering, model development, optimization, hosting, workflows, explainability, and many, many more. And with SageMaker, we managed to increase the productivity of our customers by 10x. Many customers like Intuit, Lyft, ADP, they advocate for the productivity improvements that the SageMaker suite is offering them, and they state that they improve machine learning time to value by 90%. That's a radical improvement. And they have brought their machine learning to value the time from months to weeks, if not days. And if you're in the room and you're not using SageMaker or you haven't heard of it, please go ahead and speak with your account manager. I'm sure they would be very happy to schedule a deep dive. But I'm sure many of you here know or use already SageMaker. So you're asking us, what else can you do? And I'd argue the second option you have is to actually scale the team that you currently have, the data science team that you currently have, in a linear way to match the demands, the needs that you have in terms of use cases. Well, that comes with another set of problems, and more specifically, the demand for AI and ML talent over the past 4 years is really high. Based on the LinkedIn Emerging Jobs Report of 2020, the demand for AI ML talent has been increasing by 74% year on year. And that's twice as fast as any other emerging role out there. Given how early machine learning is and how young, it really comes as no surprise to us that there's just not enough talent out there to satisfy all the needs. So what's left? Well, how about you tap into the business teams out there and help them build and use their own machine learning? How about finding a way to democratize the development of machine learning models with a completely no-code experience so that analysts and domain experts can quickly tap into the power of ML? Well, that sounds amazing, but let's see why this hasn't been the case so far. Our customers are saying that analysts are very familiar with spreadsheets and business intelligence tools, and they're excellent in doing analysis, diving deep into the numbers, applying their domain expertise, and getting insights and reports back to the business. However, machine learning needs a deep understanding across the end-to-end machine learning workflow. One needs to know what type of feature engineering is required for the particular problem and data set that they have. And they also need to know what model they actually need for the problem type. And that means that they need to know the models. For example, one needs to know what is an XGBoost and what it does. What is a random forest? What is a multi-layer perceptron? And a lot more. It's just hard, and it takes a lot of time to build up knowledge. And not to mention, it usually requires you to write code, if not be able to actually decipher code. In addition, the business teams are also asking, whenever they're using a machine learning model, to be able to explain why this model is predicting what it is predicting. They need to be able to trust that this model is the best model that they can have for the particular problem type they have. And that's the very reason they actually trust the experts, the data science teams, to help them build those models. But as we discussed, that has some scalability issues. And lastly, our customers are saying that although there are some no-code machine learning solutions out there, they lack the code-level transparency and visibility that is required for the teams to be able to inspect the code, those no-code solutions built. And they also come with a certain set of other issues, like they have licensing fees, which make it expensive to invest in no-code solutions, as well as require upfront costs. And lastly, they say that a lot of no-code solutions are actually merging the experiences of the technical experts and the non-technical experts, the analysts and the data scientists, which actually dilutes the experience in both and usually requires the analysts and domain experts to be able to understand the ML concepts and understand the ML terminology. And that is still requiring some ramp up. Welcome to the SageMaker Canvas. And all those issues are part of the past. Amazon SageMaker Canvas makes it easy for business analysts and domain experts to generate highly accurate ML predictions on their own without ML expertise and without any coding. With SageMaker Canvas, business analysts can easily access and import data across a variety of data sources on cloud and on-prem, and they can very quickly combine and cleanse them via an easy-to-use interface. And from there, Canvas takes care of everything else, from feature engineering, model development, optimization, and provides a fully explainable machine learning model so that your business can quickly leverage it. And then business analysts can either get the predictions within the UI, or with the click of a button, they can share the code that Canvas produced with their data science teams. One click of a button, and the data science teams can inspect all the code that Canvas produced, and they can actually decide either to give you the thumbs up, go use it, or they can productionalize it using your MLOps capabilities. Last but not least, SageMaker Canvas comes with usage-based pricing and helps you avoid all licensing fees. Our customers mentioned that this helps them reduce the total cost of ownership of no-code machine learning capabilities and allows them to enable a lot more users within their organization to adopt it. So let's see a couple of key features before we do a live demo. First of all, you can access SageMaker Canvas through a single sign-on experience, same way that you can access any other SaaS tool. Our customers mentioned that business users are very familiar with SaaS tools and the experience, but they're not as familiar with the AWS console. And that's why we enable a single sign-on experience. Then within Canvas, you can very quickly combine data sets from Amazon S3, Amazon Redshift, Snowflake, and the list will keep on going. And then you can very quickly, within a visual UI, join them and bring them in for understanding and machine learning development. And then with built-in visualizations, you can understand what is the correlation between the different columns. If you're missing, what is the quality of the data you're bringing in. And you can very quickly prepare your data for machine learning. And then with a click of a button, Canvas takes care of all the steps of the machine learning workflow, from feature engineering, model development, training optimization, all of that. And all those back and forth steps are not anymore there. Just one click, and you get the model that you need for your use case. And then you can get you have the option within Canvas to either get a model extremely quickly in a couple of minutes so that you make predictions and iterate fast, or you can let Canvas go through all the possible iterations that it considers that it should go through, so that it gives you back the most accurate model for your particular problem. And Canvas doesn't just give you a model. It actually offers you explainability through feature importance, and it also gives you advanced metrics in a way that is very easily understood by business users. No more jargon as precision and recall. Just easy to understand sentences, and we'll show that in just a second. And then within that UI, once you have that model, you can decide to share it with by creating a quick hyperlink with your data science team. And your data science teams will see all the artifacts in SageMaker Studio so that they can inspect and productionalize if they want. And last but not least, once you're confident, either you got the thumbs up from the data science team, or you are confident because of the metrics that Canvas provides you, you can either do what-if scenarios within Canvas, so you can make single predictions and play with the model right with the UI, or you can bring in another data set that Canvas hasn't seen to make predictions and be able to use the machine learning capabilities right through the same UI. So as you understand, with a couple of clicks and a very easy-to-use interface, we're enabling business teams to tap into machine learning while also collaborating with their data scientist counterparts to increase trust, as well as productionalize those models. And before we go to a live demo, let me answer one important question. What use cases can you solve for with Canvas? Well, the answer is a lot. And think of use cases across tabular and time series data, which our customers are saying represent more than 80% of the problem types that they have. And think of use cases across industries and across domains. In the slide behind me, you see use case across 3 key business domains. And for example, many customers want to predict the churn. What is the predicting churn of their customers? Or they want to predict what is the sales conversion on the leads. And usually those are tabular use cases. Other customers want to predict what is going to be the inventory or what is going to be the demand in the future. And usually those are time series use cases. And the list goes on and on and on to a lot more of them. For example, if you're coming from the healthcare world, think about patient readmission. If you're coming from the financial services world, think of the credit risk prediction. If you're coming from the retail world, think about the delivery time prediction. And that list is expanding and expanding. It's a lot of use cases that can be built because of tabular and time series data. But let's focus on one of those use cases. Let's take sales conversion, and let's see it live on how Canvas works. So the marketing team sent me here some data. They gave me the prospect ID. They ran some campaigns. For example, we can see if someone RSVP'd in an event, we can see the page views per visit for this particular prospect ID, the total web visits, if they're attending a marketing event, if the organic search was actually organic or not. And then the sales team gave me some lead data. Where was the lead source? What is the job role of this particular lead? What kind of nodes do we have if this lead profile is large or not? And then I have a prospect ID, which I can use, for example, to connect those two data sets. But what would I do in a spreadsheet? I'm really not sure, to be honest. So let's go to SageMaker Canvas, and let's see what we can do with those two data sets. So this is the landing page of SageMaker Canvas. And here on the top, we are about to create a new model. Let's call it sales conversion. And then we need to bring a data set. Here I have already joined a data set, but let me import a data set or two. So either I can upload data from my local disk, I can use S3 to connect to a bucket, or I can connect to my Snowflake database or Redshift. So in our case, let's upload the data I have from my local disk. I bring them in. It's going to take a couple of seconds. I can preview them. I can see that these are the data sets that I just showcased. And then I can select import. And very quickly, I have in Canvas two data sets that I will need actually to join. How can I go about joining those two data sets? Well, you can go here to join. And all you need to do is drag and drop the two data sets. And then Canvas intelligently understands how those data sets need to be connected. So for example, it understood that the prospect ID is the unique ID between the two, and it pre-selected inner join, but you can select any other type of join that you want. So let's import this data. We call it join. Let's call it live. Data set. And then in just a couple of seconds, I'll be able to select this data set. And then I'm landing in an experience that I'm asked to select a column to predict. And you see that there is language that helps you understand what is that column to predict. Choose the target column. The model that you build predicts values for that column that you want. So what is the column that I'm trying to predict here? Let's see. If I go here, it's the converted column. And if I select converted, it will give me a value distribution of the converted. I have yes converted equal to 1, which is about 50.8%. And then the rest is it won't convert. And then Canvas immediately understood what type of problem that is. It's a two-category prediction. It's a will it convert or not convert. But let's see what other types we have. Here, you can select either 3 category predictions. Some other people would call it multi-class classification. And then you can also select number model type, which is what other people call regression. And then if the dataset is time series dataset, you can also do time series forecasting. But that's the right one, the two category prediction. Let's keep it there. And then what I can do, I can quickly go and see and analyze the different columns I have. I have the prospect ID, the page views per visit. I see the distribution, how many there are. And if I want to analyze a bit more, I click on it and I see the statistics. I'm not missing any values. There's no mismatched data types. I have about 10,000 rows on that. Now, because I see that prospect ID is just irrelevant, I'll just drop it. And as you see here, Canvas immediately create a model recipe that will include the drop of that particular code. And then on the top, I have 2 options, either to trigger a model build or to do a preview model. So let's click on that. It's going to take 1 or 2 minutes, but as it does that, we'll also discuss about the other capabilities here. So what preview model will do is pretty much give you what is the more or less expected accuracy of the model given the data you're bringing in. So in a way, it will tell you, is it good data or is it bad data? And it would also give you, and already gave us that, oh, this actually data is quite good. And it will also give you a feature importance to understand which feature is more important than others, and maybe decide to drop them if they're not as important. But as it does the feature importance, on the top here, you have, as I mentioned, 2 options to let Canvas either do a quick build of your model, which means that in a matter of 2 to 15 minutes, depending on the data size that you have, Canvas will bring you back a model, which you can very quickly make predictions on. Or using the standard build, which will take more than 1 hour, depending again on the dataset size that you bring. We'll go through all the iterations that renders correct, and then we'll bring you back the most performing model for your use case. So here, and the bigger difference is that one quick model, you sacrifice accuracy, but you get a model very quickly. Or standard model, standard build, you actually have to wait a bit more, but you get the most optimal model for your use case. And the other difference is with the standard build, you can actually share all the code because you actually went through all the iterations, so the data science teams will see the best model. If the quick model, you will only be able to experience it and use it within Canvas. Now, preview model, as I mentioned, gave me back the feature importance for the particular use case. It tells me that attended marketing event, used promo, a contact knowledge, those are very important features in my data set for the prediction. And I say, okay, this is a good data set. Let's create a quick model. And then I trigger a quick build. This will take a couple of minutes, but in the interim, let's go and see the standard build, because the standard build would take a bit more than an hour. I have it already pre-trained. And you see here the accuracy of the standard build, because it was longer, it is actually higher than the accuracy of a quick build. Of course, here is marginal, but imagine for a less high quality data set, how much bigger it would be. So in the standard build, let's assume we build either a standard build or a quick build, then Canvas gives you back the accuracy, and it actually tells you the model predicts the correct converted 98.9% of the time. And it gives you the feature importance, which you can very quickly, for example, use promo. You can tell if they use the promo, it's usually that they have converted. If they don't, then usually no, but there's other aspects of the model that will actually be important too. And you can understand all those different features through all those easy-to-understand visualizations. But then you also have scoring. And here you see about 20% of the data set has been holded out for my model to make sure I'm not going to be predicting for some rows that the model actually has already seen on the training side. And you can very quickly see which ones it got correct. And here you read that if the model predicts 1, which is the converted, it is correct 98% of the time. That's actually something easy. I can understand this. Or for the values that are 1 in the data set, the model predicted 100% of them to be 1. So I have good precision, someone would say, in that. But if you want to see more advanced metrics, you say, oh, this is too simplistic for me. You can go and see the F1 scores, the accuracy, the precision, the recall, the AUC, and see the confusion metrics to understand how it performs for your particular data set. And then you have 2 options. Either you make a prediction using that model directly, or you can share it with your data science team to quickly understand if that model is performing well for your use case. So let's start with sharing that model. Then here, create a link for me, and then say, can you take a look? It created a hyperlink, which I copy, and I can share with my data science team. And then once a data scientist opens that, what do they see? They see, first of all, the data set, and I actually dropped the column, so they see the feature engineering process. But then in that, they can actually, let me zoom in, they can actually see the data exploration notebook, which any data scientist would do an exploratory data analysis. Will understand the quality of the data, the distribution of the target variables, you would do some sampling, would do some cross-column statistics, we'll see some anomalous rows, and we'll make some decisions on that. So data scientists can quickly have out-of-the-box understanding of what EDA Canvas did. And then they actually can see the best model, and they can see not only the explainability of it and the feature importance, not only the metrics that this particular model has, but also deeper analysis into the performance and the artifacts. For example, they can see the confusion metrics, the precision record curve, they can see the ROC curve, and they can see all the artifacts from not only the input data set, but the code level, the feature engineering code, and the algorithm model, the code itself, which they can inspect and can decide if they want to press a button and deploy it into their production. So let's assume that the data science team gave a thumbs up, and we say, OK, let's go predict. So the analyst can predict either by bringing in older data set, the test data set, or by doing a what-if analysis. So let's say within the UI, I want to understand how would the sales conversion change if I change a couple of characteristics. Here, it predicts that it's not going to convert. But if they were to have 5 page views per visit, or if they, for example, used a promo code, how does that prediction change? It's actually a yes. That can actually react to it. Can I improve the chances that they attend an event? What can I do there? So, as you understand, with a couple of clicks, we gave the opportunity to business teams to build and use their own machine learning models to make smart predictions, while also enable them to collaborate with their data science teams to help them increase their productivity and help them productionalize much faster. So I'd love to now introduce on stage Mark Newman, who is the product owner of the BMW's AI platform, that will walk us through their ML journey thus far, as well as discuss how they're scaling the machine learning value that they get right now. Mark?
Thank you, Kosti. Hi, I'm Mark. So as Kosti said, I'm a product owner at BMW Group. And since over 15 years now, I'm driving the digitalization of BMW Group with my colleagues at the BMW Group IT. We are roughly 5,000 people, BMW internally, and we are heavily relying on external partners to develop and operate our IT workloads. And I'm based in Munich, in Germany. That's where our headquarters are. And since the last years, my mission was to scale the value contribution in our enterprise using AI. So I'm a product owner of the AI platform within BMW Group. So why is BMW at all pursuing AI? We are an automotive enterprise, so why are we doing this? So as a start, I brought a picture of a brand new BMW i4 with me to you in this nice scenery here on the bridge. It's an all-electric Grand Coupe that we just released in this November. And I would try to connect a bit on the BMW i4, how we apply AI. So of course, we're using AI in our product features, like for automated driving or the intelligent personal assistant and other connected services. But there's much more. In order to provide premium vehicles, we have to run very complex processes. And we have to run them in quality and efficiently. And to be premium in our processes also, we are more and more applying AI. And this is the clear reason why we are pursuing AI. So AI as a key technology is an integral element of our digital transformation. But what about our journey with machine learning and AI so far? So quite some time before, like already well over 10 years ago, we were experimenting with machine learning in different use cases for different processes. But this all was kind of decentral and not well organized. So 7 years back, we founded a central organization unit to build up central data science capacity and also to enable big data and machine learning use cases. So what we did there basically was building an on-premise platform in our data centers in order to establish the enterprise data lake. Then on top of that, we built many AI use case applications in order to improve our processes. Then we shifted to cloud to be more flexible and also to scale AI more. We learned our things, we made mistakes, we collected our best practices, and we applied those practices in new use cases. And to scale AI even further, especially for next year, we need to scale beyond our data science capacities. And this is where we need to apply democratizing AI. So how are we supporting AI use cases today actually within BMW Group? So I'm from BMW Group IT, as I said. And in BMW Group IT, we have the data analytics and AI platform. And this platform is supporting all data products within BMW and adding capabilities that solves all their major problems, and as an enterprise also standardizes their architectures to avoid that we have too much technology entropy in our enterprise. We have our group data lake, which we coined the Cloud Data Hub. And in there we have all the different data from the different processes. We have a governance model on how to get access to the data. And on top on the data lake, we have the AI platform. And the AI platform provides general and domain-specific services. With general services, which are available to all the AI use cases, we standardize their application architectures, make sure that their insights are being shared back into the enterprise, and also manage to do AI governance. With domain-specific services, we solve common problems that are relevant to subsets of the use cases. For example, a machine translation service which already includes the translation for BMW Group internal terms, or like video labeling tools, which are heavily used in our shop floors to learn on quality-specific visuals, for example. And on top on this platform, we have many AI use cases that are being built and consume the services from the AI platform. But what is a typical use case within BMW Group? So as an example, I brought for you a use case where we wanted to optimize our planning processes for the vehicle special options. So vehicle special options for BMW vehicles, if you want to buy a BMW today, then you can select from a variety of vehicle special options. For example, for the BMW i4, you can select the glass roof, for example. And we are planning, before we starting production with the vehicles, how big proportion of the customers will actually add the glass roof to the BMW i4. And of course, we had processes in place to plan this with the markets for all the different vehicle models and all the different vehicle special options in order to align with our supply chain so that we can deliver the features and the products to our customers and have it available. So we brought in a data science team here to develop a model that can leverage our data history and do the forecasting on those option take rates. And we collaborated with the Boston Consulting Group also to get this fastly done. And after an intense exploration, we came up with a boosted tree model that uses well over 40 different features from different data assets, as you can see, like prices, the characteristics of the vehicle options, the vehicle models, our sales history, for example, to name a few. And then we had this model from the exploration, and we transformed it into an industrialized application, which has also like automated retraining, monitoring of data quality and the model itself, and an integration into the planning processes. So we solved like the industrialization part. And for the industrialization part, we came up with reusable best practices. Yeah? But imagine, like for this use case, what would have happened if we don't had the necessity to bring in a data science team where like a business unit could directly create the model. For the industrialization best practices, we established modules and templates that brought up a reference architecture, which is also a bit specific to BMW Group, since we have specific compliance requirements, security requirements. We have our data lake, so this is kind of specific. And now we have modules and templates implemented in Terraform with a lot of Python codes and existing examples where we can fastly create new AI applications. But still, there's the modeling part, right? And for the modeling part, we always need data science teams. So we have a corporate-wide governance process to identify relevant use cases, identify their business value contribution, and prioritize based on this business value. And so there are many, many use cases which are not prioritized. So we need a solution for this. We need a solution to scale beyond our data science capabilities. And this is where we could benefit from a tool like Canvas with low-code AI. Because BMW Group is fueled by tens of thousands of analysts, it's always a bit hard to believe, but running these complex processes, we have a lot of different analysts working in all different kinds of domains, working with different data. For example, analysts are working to understand the customer use of our products in the field in order to improve our vehicle features to develop new products. Or they are working in our planning processes to do forecasts, and they have to do forecasts for like 7 years, for example, because BMW Group is very keen on being very predictable on start of productions and vehicle volume, etc. And analysts are also working regarding quality in our production plans, for example, analyzing all kinds of measurement data, for example. So those all would benefit from a no-code AI tooling. And how would we envision on no-code AI tooling like Canvas to be used by our analysts? So first, they could use our data portal and enterprise data lake to create a new use case, get it approved, and get all the necessary data access permissions that they need in the data lake for this. And once they've done so, they can start up Canvas and then combine the different data that they got access for and build a master table for their machine learning adventure. And then they could build the model, and they already applied their domain and data understanding on their own without the help of any data science team or external partners. And then they would have a model, and they could use Canvas features on model explainability in order to understand the correlations that they have there and reflect with their domain understanding on causality. And alone with this, they could improve their business processes without even using the model for predictions. But of course, they can also use the model for predictions already in Canvas, which is super nice, so they don't need an IT application to be built. They can simply use Canvas. But if they have the need to, they can, of course, also deploy the model into the processes in order to automate its use. And for this, they would deploy the model into an MLOps-based application, which is then to be operated. Coming back to the BMW i4. So the BMW i4 is an all-electric vehicle, as I said, and it's using the 5th generation of our electric powertrain. And for the production of our electric powertrain, we have a lot of production lines who are producing the different parts, like the battery, the electric motors, and all the assembly. And those production lines have many stations, and in those stations, we are recording a lot of measurement data on a big data scale. We developed an ontology to connect the different stations, so we know for each part which data is kind of related to that. And using Canvas, an analyst who is working in quality analytics for production lines could now use the data from the data lake, could use Canvas to create a model that is able to correlate the outcome further down in the production lines regarding some variables, regarding the measurement data that has been recorded earlier. And alone with that model, he could understand the correlations and could improve the process. He could also use that model to predict the quality of certain parts or the outcome of certain result variables using early on in the process and deploy it into the get early quality feedback. So this is really great as a tool. And how do we envision in BMW Group on applying this actually, organizationally? So business units work with the Canvas tooling, with the no-code AI tooling. They build the models, they explore them, they can even update them. And we would partner them with a DevOps team. And the DevOps team would take care for the industrialization of the application. So integrating model results from inference back into our processes, running the application, taking care of like IT security findings, fixing them, making basically sure that technical and operational excellence is being solved. And business and DevOps team would form an ML Ops team, and they could also use Canvas to collaborate regarding the model. We could bring in our precious data science resources on a like request mode and collaborate also with the business unit using Canvas. So this is a great way for us to scale AI with no-code AI tooling and Canvas, and I'm really looking forward on generating business value through this and making sure that we can create the best possible vehicles for our customers. So thank you for listening. I'm happy to answer any questions during the Q&A. But now I pass it back to Kosti for some closing remarks.
Mark, what a story. Thank you. So if I were to summarize what you and many of our customers have told us, is that by SageMaker, by adding a no-code machine learning capability into their toolset, and by enabling a full collaboration between data science and business teams, helps scale their machine learning value creation from months to actually hours. And it does that by offering a fully tailor-made experience for analysts and a fully tailor-made workspace for the technical teams, for the data scientists, so that it doesn't dilute the experience. And business teams, with a couple of clicks, they can create machine learning, while a data science team can see all the artifacts and all the code that they can productionalize at their will. And that's what we call, within AWS, true democratization of machine learning. We give every stakeholder what they need in the way they need it to produce and use machine learning. And that's exactly what our customers are also saying as well. More specifically, Invista and Siemens Energy continuously emphasize on how Canvas helps them scale the machine learning value creation. Davud Naderi, the data science lead at Siemens, mentions that Amazon SageMaker Canvas is a great addition to their machine learning toolkit because it allows business users to perform experiments while also sharing and collaborating with data science teams. And in that way, they not only produce a lot more models, those models adhere to quality standards and policies that they have. So how can you see all that for yourself? Well, you can start by going to the URL I have behind me, take a quick picture, or Google SageMaker Canvas. But some key points I want to make sure you remember is, if you're an executive, please do read up on how you can further scale the machine learning efforts in your organization by giving Canvas to analysts and Studio to data scientists. And if you're an analyst or domain expert, please go ahead and test Canvas. Would love to hear from you. And lastly, if you are from the admin teams, please do read up on how you can onboard all the analysts in your organization and how you can enable collaboration between them and the data science teams. And that takes me to the end of the presentation. I just want to thank you immensely for the time and energy. Thank you for joining us physically. If you have any questions, we'll open the floor for Q&A right now, but I know we have a couple of meetings only. So if you have questions, feel free to email us, tweet about it. Would love to hear from you, how we can help you, and what type of use cases you're envisioning using Canvas for. So Mark, maybe you join me on stage to address a couple of questions. So who wants to be first? Please.
Is there an easy way to put up an endpoint for appearance?
Let me repeat the question. The question is there a way to bring up a live endpoint so that anyone else outside of the business is able to also use it in a different application? The answer for now is no. There's no way to create a live endpoint within Canvas UI, but the data science teams that they have all the code in Studio, they can quickly create deploy, which is pretty much creating a live endpoint for you. Maybe I'll give the floor to someone else, given the time, sorry. Well, there is no question that we are heavily invested in expanding the capabilities of Canvas. Right now, you can bring in text data, so Autopilot understands text data. But if you're talking about natural language processing, we would love to hear what use cases you have in mind, and would love to see how we can help you there. Yeah, yes. If I hear correctly, the question is, can we create a machine learning pipeline from Canvas in SageMaker? And the answer is that you can only do that in SageMaker itself. From Canvas, the idea is not to create pipelines, to be honest, because a business user has told us does not understand what a pipeline is. So we want to give that capability to the technical users that are using Studio and the whole SageMaker experience. But would love to hear what do you think in terms of a pipeline, maybe on the side after. I know you had the follow-up question.
Yeah, so is it easy to do like a batch job?
So the question is it easy to do a batch job? Yes. Where I showcased the single prediction, what if scenario, there is another tab next to it that says batch prediction, and you can bring in a test data set that the model, the Canvas has not seen, and you can quickly create predictions, write the same UI. So in a way, you don't need that live endpoint. You can do it in batch. Please. Excuse me? The question is, does Canvas integrate with the feature store, the SageMaker feature store? And the answer is, right now, we're not connected with the SageMaker feature store, but would love to hear use cases that you have in mind, because we're certainly expanding the gamut of data sources that we integrate with Canvas. Please.
So as a data scientist, if you make an edit to the model in Studio, change a hyperparameter or something, is that change then reflected back in the model that the business analyst will see in Canvas, so it kind of goes both ways?
So the question is, if an analyst shared the model and the pipeline to the Studio, to the data scientist, if a data scientist makes some changes, can they expose back the model to Canvas? And the answer right now is no, but it's definitely something that we have heard from others and will definitely prioritize. Please. So the question is, can we do hyperparameter tuning within Canvas? And Canvas actually takes care in the standard build experience of hyperparameter tuning as well. Takes care of deciding what feature engineering, what models to select, and what hyperparameters to optimize for. So it takes care of hyperparameter tuning as well. Please. That's a great question. So the question is there any cost controls to make sure that the analysts are not using it extensively and racking up the bill? So for now, you can use AWS budgets to set a budget for a specific account and specific service. But we would love to understand what is the granularity and what exactly you would need per user or per team so that we add it to our requirements as well. Please.
Question for Mark. What do you think is the biggest challenge for giving business users such a capability?
So for us, giving the capability to business users is like cost. This is a big thing. So we need to use what is there, like AWS budgets, and have this canvas being kind of made available through separate accounts. So we currently base everything on an account level. We have AWS organizations in place, basically. I think the biggest challenge for us is not with the Canvas thing. I think we can buy them easily. For us, it's basically regarding the industrialization, because how we would scale it basically is independent on our capacity. So we would only govern basically the service. So the DevOps teams we've seen for BMW Group would be external partners, of course. And we would need to guide them properly so that when they work with the partners, no havoc is created, basically. And that all thing happens on how we standardize it. That's the biggest challenge. I think with Canvas, having done some pilot projects, they will all buy in. I think that's not a problem. Yeah.
Well, I'm afraid we are out of time, but that was great. Thank you so much for the questions. We'll stick around a little bit more if anyone has more questions, but thanks again for the time.
Thank you.